Sure, it's somewhere around here, but after a while I'll come look for it. We got a time for us to get going. All right, inverse functions. Inverse functions. Here's an inverse function. We talked a little bit about inverse functions before, right? How do you find the inverse? Does anybody remember? John? Switch them up. It's the round trip ticket. If the function took 5 and mapped it to 3, okay, the inverse takes 3 and maps it to 5. And here's how you write the inverse. You take the original like this. You put that sign up there. That means inverse. And then you switch the numbers. Okay. Yeah, we should put these on there because that's what's in the directions. Are you going to lose points because of it? No. All right. Whoa. That's with a bunch of coordinates. That's with a bunch of coordinates. And we talked also about like what is an inverse and whatnot. But how do you do it when there's equations? So here's what you do. When you want to find the inverse of an equation, step 1. This is one of those few instances where we're going to write down steps because you need to remember. Step 1. And that's what we'll call it, step 1. Rewrite f of x with a y. So here's what it is. It becomes y equals 2x plus 5. That's just to make the next few steps easier, honestly. Right? So there's the equation. Then step 2 is, right, this is the round trip ticket. We are going in reverse. We are switching things around, right? That's what we did in our other problem. So what should we do to x and y? Switch them in the same way that you switch x and y in the coordinates. You switch x and y in the equations to find the inverse. Switch x and y. So it's going to be x equals 2y, bless you, 2y plus 5. And then step 3 is going to be to isolate y. So we've got x equals 2y plus 5. We're going to subtract 5 from both sides. X minus 5 equals 2y. We're going to divide both sides by 2. You get x minus 5 divided by 2 equals y. I'm going to put it on pause for a minute. So our final last step is to distinguish which one is the inverse from the original, right? If they both are y equals, you wouldn't know which one goes which way. Rewrite the formula that you just did with a y inverse symbol. That's this -1 up over here. It's never -2. You can't put another number up there. That's the one that symbolizes the inverse. And there you go. You could do it like that. You could write it you could write that, or you could say this. Oops. Right? You could say f inverse of x. So you could have written it, if the y's are confusing to you, you could have done it like this. I know it's a bit random. Is it really that difficult, though? No, it's just a language. We're learning to speak our language. New language, I'm sorry. So do me a favor. Let's see. Can you try and do 25 for me? So this is the kind of work that you should do. Kx is subbed out by y just to make it easier to like keep track of stuff. Switch x and y, try and isolate y, switch out the y, make it y inverse just to remind yourself that that in the end is the inverse. That in the end is the inverse. All good? All good in the hood? We're going to do one more example, and then we're going to be using our calculators a little bit, okay? One more example. I mean, these were easy problems. How about something where they give you something like a little bit more difficult than just a straight up line? Let's switch back. Let's do 23. Let's do 23. 23. Suppose you got x cubed plus 2. Whoops. So here's how you might do it with something more complicated. With something more complicated, right? You just do the opposite. You're trying to go exactly the way that you came in reverse. You guys all just got your licenses, right? It's easy to drive forward. Have you been practicing driving backwards yet, though? Is it useful to be able to drive backwards? Of course it is, especially when that parking spot frees up at the back at the end of that street and you have to go in reverse real fast. You know what I'm saying? Yeah, exactly. Anyways, all right. So now we're going to put it on pause. Everybody's going to grab a calculator, and we're going to talk about what this looks like in a calculator. All right, here we go. Come on. This is easy. This is easy pickup points. Freebies. You just have to remember something, right? And I'm just going to show you why it works. So go into your y equals screen, enter the original. Suppose you're given an equation like this. I know somebody's going to ask me, how do I enter this to the calculator? There's like an f of x. What's f of x the same thing as? Good, so we're just going to sub it in. We're going to plug it in. We're going to do 2x plus 5. And then here are some things people didn't know about their calculator. You can color in lines. If you scroll all the way to the left to this blinking part and push enter, that's like bold if you were in Word. Okay? Check it out. Your graph will look like that. Hold on 1 second. There's just the original. Let's do this. Some people have different calculators that have been messed with. If your calculator, the window's all messed up, and you don't like fixing it because, that's something you were never good at, hit zoom. Zoom standard puts it always back to this original 10 by 10 window. Okay? Okay, now let's go down to the inverse. Here's our inverse. X minus 5 divided by 2. You're going to have to be careful how you enter this in. It's going to be x minus 5 divided by 2. And we want to look at the two. Let's go to. Tell me where I messed up. I put 2 parentheses. There's the original. Here's the inverse. And what we're going to try and do is see if there's any relationship between the two, graphically. Sure. Dude, okay, all right. Okay. There you go. Yep. To remember. Yeah, to remember. But you won't have to in the future, all right? So here they are, right? And so so now I'm going to go into the screen. I'm going to show you something. Everybody put an X here. Also, to indicate that this one is different, let's give it this little, whoops, I want the circle. That little circle thingy. I think that's the right one. Let's see. No, that's the wrong one. That's the circle. That's the circle. I want to go down. I want to give it the what? Hold on 1 second. Yeah, I want to see. Oh, I think you can. All right. Anyways, it doesn't really make a difference. I was just trying to highlight the difference between all 3 lines. So the bold one is our original one, right? This one over here is the inverse. Now this line cutting through, would you say it cuts through the middle? Exactly the middle? Would you say, remember when you learned about parabolas and the axis of symmetry, right? Would you say that this thing is cutting through so that it's like perfect distance away from it on either side? Look. What, this side? All the way to the ends? Not that they maintain the same distance. Like I agree, these are further away from these. But take a look. It's like they're a reflection. One's a reflection of the other. Yeah? Okay, good. Well, I'm trying, I'm not going to lie, I'm leading you on to this. So what happens is that if you don't want to have to do this long process of finding the equation, you just want to find the inverse from a picture, reflect it over the line y equals x. Reflect it. In fact, in geometry, you would have learned about this. You remember like transformations? Like dilations, translations, isometries, yeah? It turns out reflections, do you remember what reflections do to coordinates? What do? Certain reflections, sorry. If you reflect something in the x-axis, it changes the y-coordinate. If you reflect something in the y-axis, right, it negates the x-coordinate. And if you reflect something in the line y equals x, it switches the coordinates around, which by default is what the inverse is doing. So, this is super important, easy points. The inverse of a function, whoops, instead of a function, that's just long words. The inverse of f of x can be found graphically, whoops, through reflecting f of x in the line y equals x. So it's always y equals x. Those are give me points on your test, give me points on your regions. You reflect something through y equals x, by default, doing that reverses the coordinates, and that's really what the inverse asks you to find. Let's just take a look at some of our, we're going to take a look at some of our other equations that we just found the inverse of, right? Like, take a look at this one. Negative 3x plus 8, right? The inverse was, parentheses, x minus 8 divided by negative 3. Let's just see what they look like. There's one, there's the other, there's one, there's the other. And then here's our line, y equals x, and I'm actually going to bold the line y equals x. All right, look at that. Cuts it right in the middle. It's a reflection, a fold. Think of your piece of paper as this thing. If you fold it right over that line, boom, perfect. What's up? Let's talk about that. Your calculator will actually draw the inverse of stuff. Like, for example, take x squared, for instance. X squared is this. X squared is this. Do you think x squared's inverse is a function? Why not? I told you that in order for the inverse to be a function, it had to pass this test. Now, that tells you the original is a function. The horizontal line test tells you that the inverse of whatever it is you're using the horizontal line on, if it passes, the inverse is a function. Does this thing pass the inverse? Does this thing have an inverse that's a function? No. And the problem with that is your calculator was designed so that it will only graph functions. Right? Well, that's annoying. Suppose I needed the equation or graph for, I don't know, any particular purpose, I'm not sure what. How would we do it? Well, second, draw. Draw is right above the program button. And if you scroll around, this is something random. It's not too useful, to be honest with you. Draw the inverse. Now, you have to tell it to draw the inverse of wherever the equation you had was. So we go to vars. Y vars. Vars stands for variables. Function, y1. And then watch. If you hit enter, it'll draw the inverse in for you. And that's what the inverse of that function looks like. So you could literally be able to check your answers like that. If you took the original and did all that, and then wanted to see if your answer was correct, if it drew the inverse directly over your answer, you'd be totally right.